Good morning, ladies and gentlemen. We're going to make a start. We know there are some people still signing in, but we have a fairly tight schedule this morning, so we'll go ahead and get on with it. My name is Colin Meckiff. It's my privilege to be the first to welcome you to this ALIAS Conference here in beautiful Fiesole. The reason I get to do this is because I'm the leader of the group of projects within CESAR, of which ALIAS is a part. This group of projects is called Long-Term and Innovative Research, and essentially we're trying to try out new ideas, experiment with new things, and ALIAS falls well within that group of projects. I've followed this project for two or 3 years, and I have to confess I find it quite a difficult project. I'm an engineer by training, and and apologies to the legal people amongst us, we have jokes between us, the engineers and the lawyers, but it's good banter. I like to see things in the form of equations where you have x equals a plus b over c or something like that. So we write down an equation, we know what a, b, and c are, so we can work out x. And that's the answer. We can be a little bit tolerant about uncertainty, so we can say X is the answer with a certainty of 75%, and the rest of the time the answer is something else. We can do that kind of thing. But generally speaking, for an engineer, 1 plus 1 equals 2, okay? And engineers have been trying to understand air traffic control for some time and trying to produce models of trajectories of the way air traffic controllers behave, of the way airports operate, and so on and so forth. I'm not sure we've done a very good job of it. So I'm not convinced that engineers are the best to produce those kind of models. But one thing we can do is provide automation. So once we've written down our model of air traffic control, once we've expressed how we think it should work, we can actually capture it in electronics and software, and we can automate the system. Mathematics is provable, so engineers, we can write down equations, we can actually produce formal proofs that what we say is correct. We capture it in electronics and software, so what could possibly go wrong? And that, of course, is why we're here, because things do go wrong sometimes, and then we want to know what the consequences are. The reason I find this project difficult, I think, is that for lawyers, 1 plus 1 doesn't always exactly equal 2. And I've been in many long discussions about automation and air traffic management and so on and so forth. And I think the fact that it's difficult and complicated doesn't mean it's uninteresting. The fact that it's complicated and difficult, I think, means that we should have a very interesting 2 days discussion on the subjects at hand. So I welcome you to this conference. I'm going to hand over to Giovanni, who will give some introduction and some logistics, I think, and then we'll get on with the rest of the program. Thank you very much.
Okay, thank you very much. I'm Giovanni Sartora. I am working in the project, coordinating the Florence unit that works on the project together with the Rome unit. So, welcome to everybody here in Florence. We are now in Villa La Fonte, which is one of the villas that are part of the infrastructure of the European University Institute. This is the second on the ALIAS project, and it is connected, it is embedded in the ALIAS project, of which was introduced so kindly by Colin. I will say something about the engineers later. So, what are the purposes of this conference? We want to discuss together emerging issues pertaining to liability and automation with regard to aviation technologies. In this conference, we are not going to have only some lawyers, but, sorry Colin, we're going to have also judges and other and other participants in the legal work involved. I think it will be very interesting to have this kind of interdisciplinary conversation. We want to gain novel insights, in particular on two very important domains, RPAS and ACAS-X, two important technology. One is already with us, at least the ACAS is already with us, ACAS-X is coming, and RPAS are also with us. We want to have to offer to the whole ALIAS network community. We have established a network of people that are interested in aviation and in the legal issues of aviation. I will say something on that later. We hope to get feedback on what we have delivered, what we are delivering within ALIAS, and find new opportunities of collaboration. Here you have a quick program, a short program of the day. If you have any question, logistic question, please ask us. Ask us, the people working on the project. We will be able to give you any kind of indication. So this is the program for today. We're going to have lunch here and continue until 4. At 4:30, there will be buses taking you to downtown Florence, stopping also at the Villa Stella if you're there. And then we are going to have a meeting. One aspect of the ALIAS project are also user groups meeting when we try to understand the legal issues emerging from the new technologies that we are examining and devise possible solutions. So the first meeting on the user group on ACAS-X will be held this afternoon. And then we are going to have a social dinner. All invited to Pentola dell'Oro, which is a restaurant downtown in Florence. The second day we are going to enjoy the cooperation of the Center for Judicial Cooperation, which is also part of the European University Institute and aims at providing an infrastructure where judges of different European jurisdictions can interact and interact also with the academic community and the legal profession. We are going to have a panel on liability for innovative technology, and then we are going to have another panel, one on systemic and organizational failures, and another on design failures and technological development. Then we will have a final panel where we will discuss the legal issues emerging from VP projects and establish, strengthen the contacts between the ALIAS project on the one hand and these other initiatives. This is all. My purpose was just to introduce to you the program of our conference, and I'm very happy, we are very happy to have you here, and we look forward to these 2 days together. Thank you very much.
Okay, I should introduce the next speaker, who's Michael Standar. He's Chief of Strategies and International Relations in CESAR. Many of you have heard of CESAR, some of you may not have, so he's going to give you a little introduction and talk about lessons learned from CESAR on automation.
Okay, so before we get all the slides up, I'd just like to introduce myself and tell you a little bit about my presentation. I was looking at the title here about automations and lessons learned from CESAR, but seeing the audience, I think I'll take a little bit of a wider picture with some conclusions at the end of issues which are lessons learned most probably from a sort of a broader, wider range than just pure automation. It'll come into the game. I will address some issues around the cooperation internationally and globally, because at the end of the day, that's where we're going to come in and really have the real discussions. So I'll do that. But I suggest, because I've only got 15 minutes, so instead of taking questions here, I think maybe there's a good discussion ground that we can have offline and talk to all of you. I also see that there are lots of members in here from CESAR Joint Undertaking, so if I'm completely wrong and I'm saying the stupid things, please step up and tell me and tell the others that he was wrong this particular time. Anyway, Colin mentioned this 1 + 1 being 2 from an engineering perspective. I'm a controller as a background, so for a controller and operator, you know, it's like a pilot. I see Christian here. 1 + 1 sometimes gets to be 5 as well, depending on how you sort of extrapolate the issues. Now, before I go into the lessons learned, just to make it very clear that the legal framework under which CESAR operates is under the single European sky. I hope that is very, very clear to everyone. So CESAR Joint Undertaking, who manages the development phase, is just one of the pillars here, which we in sort of political terms are calling technology. Technology doesn't mean here technical systems only. It means operational procedures and so forth. But there are other means here, like the airports, the human factors issues, the social dialogue, the safety, of course. I saw ALIAS is in here. So that's another element of it, and of course a big performance scheme that's running. So all of this is in the context. And technology pillar is managed by the SJU for the time being. I might tell you now that the CESAR deployment manager, which is up on the table, will also use the same logo as CESAR Joint Undertaking. That will cause a little bit of a problem as to who's who, but the deployment part is coming up in a short time frame. Now, I show you this one mainly for one reason, that these are the fundamental changes to ATM, or air traffic management, that we see. It is a very short, chip-sharp picture, which is exactly the same as the ICAO ATM operational concept. It just puts it down into small bits and pieces. Looks very, very simple, but there are issues around it, of course. It is not the goal that seems to be the issue, it's really the transition towards it. But I'm showing it because it's not completely new to air traffic management. The same system as we're projecting here for the complete holistic air traffic management and aviation chain tomorrow has been in operations in air traffic management since the 60s. But where? In the military. And I'm saying this because it is actually been operating. There are loads and loads of information and experience about it. And we're sometimes trying to say to the military, be more offensive than defensive, and you'll see that you can help us out for the future. Now, just 5 changes, simple. So what is all the fuss about? And why does it take so long to get there? Well, the devil is in the detail, of course, and I'll come back to that. I'll show you this one because it's what we call the innovation pipeline. You probably heard about it. It is a way to say that whatever we have as an idea from the early exploratory research, whether it's long-term or scope, it doesn't really matter. It starts somewhere with an idea, it has to flow through the system. And this is probably what you've seen from CESAR so far. The most focus here has been on deployment. How do we move the research parts into the real deployment? That has been the real focus. Now, it doesn't mean that we've left the exploratory research, but we need to do quite a bit more to connect on that side. The context here of the early research needs to find its place in this big jigsaw puzzle. Now, you know these are the networks, and it's all about what we call low maturity research. We might come back to what low maturity really means, and I guess through the panels we will discuss it. But low maturity could still mean a very, very good idea, but you need to flesh it out in some sort of ways all the way through. So it could be a quick ride, but I think we need to come away from the fact that it always takes a long time. Some ideas might race very quickly through the process, and we've got a couple of examples already now, which from an ATM perspective is pretty short. Remote towers, I always talk about that one. It's about 9-10 years from early idea until where we are today. Now, RVSM, reduced vertical separation minima, took 27-30 years, so it is quick in that context. Now, one of the issues here from the work package E, if I understand what I've seen so far, is that it's been extremely difficult to understand how you move from a low maturity V0 to V1 or even to V2. How do you get these criteria done in a proper way? And I think we need to work on this to clearly understand it. I know EU CVM, it was there to develop towards a concept, bringing in the TRLs into the discussion. There are criteria there, but maybe it is those criteria we need to look at and be more concrete as to what they mean when you move through the process. And I think the long-term research, whatever it's going to be, or exploratory research in the CESAR 2020 program, this has to be fleshed out. We also got a scientific committee. I know I've got boring slides, there are lots of text, and they're very busy. I'm not going to go through every bullet. I'm just going to point to the fact that there is a scientific committee. It was placed to advise the CESAR executive director on any scientific elements that needed to be addressed more properly, what they saw from the program. My personal opinion is that this one doesn't quite come down to that level of bringing out results and thinkings from work package E or from exploratory research and say, this is what we need to look at. They need to be more active, but I think they can be more active by the exploratory research projects pushing them to do something. They could be more active because we, as the SGAU and through the executive director, is pushing them as well. But it is a very important tool to address the right topics for the future. Now, lessons learned from the bulk of the program, which is about developing and putting things into context and eventually validating them. It has been extremely important for us to run this, mainly because it brings all the bits and pieces and the experts together into doing it. And I'll just show you this one, because during the course of the last 6 years, we've done more than 400 exercises at different levels, of course. The just exercise planning and execution is about 22,000 days. 8,000 experts have been involved from all these different kinds of stakeholders. And I'd like to stress that one of them, and I wrote staff associations with an international validation team, extremely important tool in here. Not only do they represent the operational knowledge in here, but they have the clear experience of doing cross-fertilization between different nations and states and people from different airlines or ANSPs or what have you. That has been very, very important. And the move here has been to move from simulations, paperwork, into real-life operations. So this has been a clearly good investment for us to say, look, let's take it out to the laboratories and get into the real life as close as possible. Now, the other one, which is the lessons learned, is to demonstrate this. Now, we call them demonstration because they were built on the fact that use whatever capabilities you have on the ground and in the air and see what can that give you in terms of bettering procedures, behaviors, and so forth. And of all these demonstration activities, we have had about 85% of what comes out of there has actually gone into implementation already. It just proves my point that doing it as close as possible to operation, demonstrating in real life, seeing is believing, and it creates a chain effect into actually moving forward. RPAS, I know I'm not going to spend too much time on RPAS because we'll come back to that in the first panel, but I'd like to show you this one just for the fact that we know we have activities going on RPAS in Europe, and this was a way for us to start capturing what is happening out there. What experience have we made? What kind of gaps do we see for the future? And how can that feed in to the CESAR program of developing whatever capabilities we need to develop for RPAS in the complete system? We're going to continue with these large-scale demonstrations. These are just some elements. I'd like to focus on the first one. It seems like the most important thing right now, if you're an industry, manufacturing, service industry, you're an airline, or you're a pilot, you're a controller, you're an ATSEP, you need to look at this from a global interoperability perspective. Because at the end of the day, we need to have some sort of rubber stamp and approval at a right level from ICAO. Some places in the world don't have anything but ICAO material to operate aviation and air traffic management. So for our industries to sell services or products tomorrow, and for controllers and pilots to feel confident that this is safe, it has to go through this. So demonstration in this context across the globe is going to be of high value for and a good focus for us during 2015, 2016. I will come back to a few elements of it later on. Now, supporting deployment, I showed this before, and I'm just showing it because there are a number of solutions, we call them solutions out of the CESAR program, where you package things together, where there are operation descriptions, technical specifications, safety requirements or cases or what have you, they all get packaged. Not everything gets into what we call the PCP, or the common projects, pilot common projects, which is the way to pile them together for the CESAR deployment managers to actually deploy over Europe. And why aren't all of them in there? Because some of them are of a local or regional nature that you do not have to put them into a pan-European program of deployment. I come back to remote towers again. It's not part of this, but nevertheless, it is something that is ready for an investor to go for. But these represent what we feel are areas where we need projects to implement them in a synchronized manner all over Europe. This is our 2020 vision. This is, I know some of you probably heard the close out of the current program, we move into the next one. So this is the vision of what we're trying to pull together. It's slightly different to the one you saw before in terms of vision, but in terms of concept, it still follows the same concept I showed you in one of the first slides. 3 phases of research: exploratory research, industrial research and validation, what we call applied research, very large-scale demonstrations. You might ask me now, the very large-scale demonstrations, are they really research? And I think to an extent they are, even though they will be built on what is currently available on the ground and in the air and demonstrated. But there could be safety cases around doing something on better versions of standards or flight equipment or ground equipment, and that would be part of the demonstrations. We pushed this issue of having sort of a more liberal kind of framework under which you could demonstrate things in a more close to operational environment. So you would consider them being an area where demonstrations would be part of a research phase, feeding back in and connecting this chain I talked about earlier. Now, a few words on global cooperation. I saw from the agenda that someone will be here from the Eurokai Working Group 75. There he is. But I'm mentioning this one because not only is it important for CESAR and NextGen to work together to find harmonization towards standards or harmonization in sharing and supporting one another into what could be ICAO, Eurokai, RTCA standards. But the transition process of the results of CESAR and NextGen into standardization bodies like Eurokai and RTCA is very important. CESAR is not developing standards, make that very clear. It's done either through the standardization bodies of the industry or in ICAO. That's the way it works. But we need to transfer across and make good use of them as close as possible to ease the work of these standardization bodies. I also mentioned the ICAO and the GAMP, which is ultimately where we would like to see things in terms of roadmaps for avionics, on ground systems or whatever. It is important for us. But it's also important for us to tell ICAO to make better use of the industry standardization bodies and not do things themselves. And here's a bit of an area where we need to come to a good discussion. Now, on the NextGen one, which are the most important and key issues that we're discussing for the time being with the US? One is architecture. We know we got SWIM, we know we got data communications, a number of things are coming up. And we need to come together to clearly understand this concept picture I showed you earlier on. What is the mirroring architecture we're looking for? And we need to come to a harmonized approach as to how we would go about it. Second one is wake turbulence. New separation criteria for wake turbulence, making best use of the capabilities on board the aircraft, making them more dynamic and so forth. The standardization roadmap of ICAO and the standardization roadmap, whether it's avionics and ground, is something that we need to have a very clear view on, especially when it comes to the content of the standard. The timeline and the synchronization is less important, I think, because it's not about one size fits all. It has to be done, and when it's done, it has to be done in a synchronized manner. RPAS, we'll talk about that later on. Cybersecurity is a new thing coming up, and we're framing that mainly around SWIM and information management. We think that's the main part where we need to look at it. There are elements on RPAS, there are elements on data communications where we need to take cybersecurity into account, but we'd like to frame it first to understand what we're talking about and put it into the right place. Remote tower services. The US are extremely interested to move to remote tower services. Why are they doing that? Because they got the fatigue issue, number of towers that needs to be open, so that's a solution for them they're interested in. Data communication. Now, when we say data communication, we need to separate out issues like protocols, services, and the pipeline or the data link itself. SWIM, information models, clearly up on the agenda for something to work on. 2 collaboration projects have been established recently. One on initial 4D, trajectory-based operations, with the Datacom issue involved. Second on SWIM, on global demonstrations. These are areas, and they will all be described in what we call a CESAR Next-Gen State of Harmonization document, which will be available publicly to the EU and the US FAA by the end of this year, 2014. That's a document I think will be very interesting for quite a lot of people to say, where are we? What are the challenges ahead? Now, so my conclusions. I know I'm a little bit stretching the time here, but I'd like to just to conclude a couple of things in terms of lessons learned. It is about managing change. We need to understand that this is change management. We need to connect that innovation pipeline, both in terms of scope and in time. And we need to cover the gap between exploratory research and industrial research, extremely important. We need to understand that there's something which I think is important for all of us to see the current business models and the evolution of business models. It links back into infrastructure and services. I often say that today is about 80% infrastructure, 20% services. Tomorrow you'll have 80% services, 20% infrastructure. Now, that represents a huge change in the business and the business models. You will see new actors coming in. It'll change roles and responsibilities. The trust is an important thing. The goal seems to be clear to everyone. Let's focus on the transition. Let's not talk so much about the goal if it's well understood. But when we deal with the transition, regardless of the area, let's understand the objectives. Play good time into understand the objectives and move on from there. And the devil is in the details. Let's remember that we need to see whatever piece we're working on in the overall context. We don't want silos. We don't want someone saying, I've got this magic fix. It's not going to happen. Let's see the context, understand the objective, and let's move on from that. Decision on design needs to be taken very early in the process. And what we've noticed is that sometimes design decisions are not taken. So we move on with different options, and we don't take them at the right crossroads. Understand where are these crossroads where decision on design is to be taken. Focus on standards. Very, very important. It is a way to get people to find trust here. Automation is business and innovation driven. When we come to RPAS, we'll clearly hear that that's where the whole thing is coming from. It's business and aviation, business and innovation driven. We need to find best practices out there. Where have other lines of businesses worked on things? And what can we learn from that? How can we adapt it to aviation and ATM, which normally is the one that requires most safety, all the different high-level quality arrangements that you need to have in place to make sure you can go in there. I think I'll stop there because I think I've run over my time and I've probably bored you a little bit. Thank you.
Thank you very much.
Not bored, I'm sure, but I think we'll have time for maybe one question, if there's something burning from Michael's presentation, a question of understanding possibly. No, we're okay. In any case, Michael will be around for the rest of the day and this evening possibly as well. Yeah, so you'll have plenty of time to collar him or any of the other CESAR people that are in the room. Now we're going to have Giovanni, who's going to talk in a bit more detail about the ALIAS 2 project.
So this presentation, I will try to give you an idea of what is ALIAS, what are the outcomes of the ALIAS project, and where the project is moving to. So the ALIAS project has 2 phases. The first one was concluded on 2013, and now we are in the second one, ALIAS 2, which will go on until 2016. We have developed 4 projects, 4 results of our project that I will present to you, the legal case, ALIAS network, the digital library, and the conference. So I will go quickly because time is limited, so we thank Eurocontrol and SAU for supporting us. We were the only project dealing with legal issues, and we believe the legal issues are in fact an important matter for also successfully bringing worthy projects into the society, into the market. Into making a business case, you must be sure that also the legal aspects are taken care of. Let me say that it was also a good opportunity for establishing a great interdisciplinary cooperation, when we have learned a lot from our friends engineers, both those working in the project and those of Eurocontrol, and I hope that also they have learned something from us lawyers and experts in human factors. 2 partners in the project, the European University Institute and Deep Blue. Now we are in ALIAS 2, which aims to consolidate and apply the legal case through validation, and we have our test cases to deal with that, to extend the network, and also organize pilot session training and coaching on the legal case. We are finalizing the legal case as a final product, and but we need to test it and see whether it is really a useful methodology for addressing how it can be made a most useful methodology for addressing legal issue during the design of a project. So the context, I skipped that because you already know, will be the what happens with automation. There are changes in the ways in which humans and technologies interact. Humans become controllers and supervisors rather than operators. How do liabilities shift? We have studied also in general the change, sorry, it's going by itself, it's autonomous. We have an autonomous computer here taking decisions on where to go. So we have analyzed the various ways in which the liability for damages caused by technological failures can be allocated, the grounds on which this liability may be attributed, and we have observed that there is a change going on when the liability moves from the operators to the organization and the developers of the technology. This also meets the safe culture debate to which we have tried to, which we have included in this legal framework. So on the basis of this background research, we have developed these 4 ALIAS projects. You can find also a Deplian where in your folders where these 4 projects are described. Again, it is going by itself. So we first have the legal case, then we have the network, the library, and the conferences. Let us start with the legal case, which is the main outcome of ALIAS. The legal case is understood as a novel methodology to address legal issues of automated technologies for ITM at the design phase. So we have described in our document a standard process to identify legal liabilities. The idea is that legal problems should be, possible legal problems should be identified in advance and met through convenient technological or legal arrangements. We are now developing applying this approach to specific technologies such that ACAS-X and RPIS. And in the course of the legal case, a variety of supporting tools, tables, flow diagrams, reports, graphs can be used to develop the legal analysis and to also to develop this analysis in a way which is congenial, more similar to the ways in which technical experts, engineers are used to approach problem solving. 5 leading principles, the idea that possible legal effects, legal consequences, liabilities, especially negative legal effects, should be addressed at the stage of design. We need to be proactive to anticipate possible problems rather than having to face them at a later point, when legal problems may even stop the deployment of a new technology. For instance, fear of liabilities today are also a big issue to be addressed, for instance, in LPIS, and there are some important also judicial decisions which are having an impact on the development of ACAS techniques. We try to adopt a socio-technical approach that is to merge the legal understanding with the understanding of the system in which the issues take place, which not always lawyers do not always do. They focus on the individual operator rather than seeing the operator's activity in the context of a socio-technical system where technologies have an increasing role. And then multidisciplinary approach, the integration between technical and legal knowledge. This is also something I think important also from the cultural side. Let me make just 1 second a citation from a great mathematician. He was the inventor of calculus, the tool that Colin is using, which is Leibniz, even though the English still say that Newton invented it, but yeah, we don't want to open this discussion. Anyway, he was also a lawyer, and he says that just as the mathematicians have excelled above all other mortals in the art of reason, of the necessary, so the jurists did in the logic of the contingent, on these kind of uncertain things that we were speaking about. And we, mathematicians, he was saying, can learn much from their precept about proofs, presumptions, conjectures, and so on. So there is a space for learning together. Okay. And then going back to ALIAS, standard case-based approach, the idea was that the legal case should be seen as one of the cases, together in particular with the safety case, but also with the business case, human factor case that are developed within the CESAR initiative. The first step of the legal case, first you have to understand the concept, try to figure out how, for instance, ACAS, X, or RPIS are working. This requires collecting background information, identifying the level of automation, and possible failures. One premise, the process of the legal case is supposed to be a process that is in which a team is engaged that involves a legal expert, but also technical people and the main stakeholders involved in a project. So business and also regulators, possibly. Identifying the possible liability risks that emerge from the project, examine them, then engage in legal analysis, that is, what happens if this safety or other risks of accidents, malfunctions takes place from the legal point of view. And then see what can be done to address this legal issue in such a way that they do not question the viability of the project, and that a fair allocation of the risks and costs is provided. And then, obviously, the outcome is provided. What are the outputs of the legal case? There are descriptions of what happens of the result of these different stages. the analysis of how the concepts operates, what tasks are allocated to each human or technological component, what are the possible failures of both human and technological failures, and then, or systemic failures as well, organizational failures. Then, what are the risks that there may be a legal liability following from a failure, and who is going, according to the existing legal regulation, to be responsible for that. And then how can we address these liabilities, maybe shifting from one person, from one agent to the other, or even involving regulators and standard setters in such a way that the liabilities are prevented through maybe a stricter standard or a redefinition of some aspects of the technology. And which is the fourth step, which is delivered in the fourth step, where you have recommendations and proposal for changes. Now we are into the test application of the legal case. The legal case already exists, is a well-structured document that we presented at the end of ALIAS 1 and that we are currently refining. We are moving into the test application of the legal case, and this test application will involve at first the two technologies that we are going to examine in today's session. That is, on the one hand, the ACAS, on the other hand, the LPAS. We obviously rely on Eurocontrol and CESAR joint undertaking for support in identification and involvement of stakeholders, and we thank them for the support we already got in connection with the ACA6 test application. We are going to have interviews, ideas for validation, objectives. At the end of the test application, we will, on the one hand, have examined the legal issue pertaining to the technology we are considering, so we will be able to provide, hopefully, some useful outcome to be used in the development of these technologies by the involved stakeholders, but also we will have some inputs, some feedback on how to improve the legal case. Let me now move into the second point, the second outcome of the ALIAS network, which is the ALIAS network of legal research. We have tried to establish a community of reference within CESAR, which has been helping us in discussing the legal issues and the development of the legal case, but our idea is also to make it into a kind of reference community within CESAR for discussing emerging legal issues. So you're also invited to participate and to submit to the community whatever legal issue you may find pertaining to automation in aviation, and to engage in the discussions that are already taking place within the network. We have already more than 160 experts from universities, research centers in the industries, regulators, international entities, and both from the legal and from the technological backgrounds. And it's very interesting to see how these different perspectives merge in debating issues pertaining accidents, near misses, or the emergence of new technologies. If you go to the website of the ALIAS network website, you will have an environment where you can engage, you can see the discussion going on, and involve yourself, participate in these discussions. Okay, here you have some examples of comments of the introduction of a new theme, and then MH17 accident, and how posts were introduced, comments were introduced to this post to develop the discussion. But obviously, if you go to the website, you can have a larger set of examples of what is going on there. The one further element, outcome, is the ALIAS digital library. You can find it on the, always on the ALIAS network website, and there you have the legal case, the outcome of the ALIAS project, various deliverables that we have been producing, but then you have also a set of reference materials, readings concerning accidents, legal issues, regulations, background material that is useful for knowing what are the issues at stake and also what are the legal sources that may help us in addressing such issues. Okay, this is another example from the library. You are invited, obviously, to register to the website. It is open and free. You can register, but you have to register before using it. And then the last outcome of the ALIAS project is the ALIAS Conference. We are already here, which is complements the virtual environment of the ALIAS network, the ALIAS website, with an annual event which is meant to discuss, to give us ideas, inputs on the development of ALIAS, but also to discuss emerging problems concerning automation in aviation, always through the interaction between the technical experts, the legal experts, and stakeholders and policymakers. We had another conference last year, in 2002, and now we are into the second of our conferences. Another one will take place in 2015. All conferences take place at the European University Institute, where we are now. Let me say just a couple of words about the European University Institute, just to finish. It is a big structure which was started operating in the end of the 70s, but then it is grown, and now it is a community of about 2,000 researchers in social sciences. We have law, history, economics, and politics. We have also a Florence School of Regulation that deals with regulatory issues in various domains, in particular in energy and transport, and there's going to be a conference next Friday on issues pertaining to aviation. We are working in strict cooperation also with this initiative. And I think that it's very good also that we succeeded in establishing a connection between a company such as This Blue, which has been working for a long time in aviation, the European University Institute, and the European CESAR joint undertaking and Eurocontrol. I think is an ideal framework for developing research on such a matter. So thank you very much for your attention, and thank you for being here.
Thank you, Giovanni. I think just a word about the digital library. Actually, there's a lot of material there. I don't think Giovanni quite did justice to the 2 or 3 years that the project's already been running, and a lot of stuff, for example, analyzing previous cases, both in ATM and in other domains where technology has played a role. So I do recommend the digital library to you. There's plenty of stuff in there. And I think that it might be difficult for some of you coming in from zero and listening to what's being said to actually catch up very quickly with everything that's gone on in the past, but it's all there available for you. We have time for a question or two if there is one or two. Where did I see it? Yeah. Okay, if you identify yourself before you say something. Okay.
Thank you, Mario Sciaburri from SICTA, Italian Research Center owned by INA. INA is Italian Air Navigation Services provider. So I'm not a lawyer, of course I'm an engineering. So what I would like to just for my curiosity, what I saw is first time I saw your project, your network, and your approach from a legal point of view is a classical approach that we will done during the process of validation of new concept that will be improve the air traffic management. By the way, I have two questions. One of these is okay. So you approach your discipline in the same way that will be executing during the validation phase. Have you think about how you can mix you can mix your process in the other one, like safety process, safety validation, security validation. So I mean, the last time we had a large discussion in our community about do not replicate exercise and so on. So during in one touch, we will be able to produce a validation objective, a validation outcome, and so on. So have you think about, I'm sure of that, by the way, this is my question, have you think about how your process will be mixed to the existing process that will be focused on safety, security, and so on? Thank you.
Certainly, we have thought about that, and our project should be integrated with the other cases. The idea is that certainly the legal case should use the inputs of other cases, such as the safety case, and it should be able also to provide input to other cases. In particular, it should also use inputs for the human factor case and provide input in general to the business case. So the idea is it should be integrated within the other cases and use inputs from them and deliver its input so that it contributes to assessing the viability of an initiative. The idea is that also that within the legal case, we should be able to provide legal regulation, both private regulation, that is through contracts, agreements, insurance, so that legal issues may be addressed. For instance, the legal issues emerging from a technology such as RPIS can be addressed in advance, and in particular also of having a dialogue with the standard setting and regulation, as I said, so that these issues may be, if it is not possible to address them at the private level, can be moved at the appropriate level. We thought that, no, we believe that currently there is no such a space for a legal analysis in the existing cases, and we are meant to cover this gap and not to replicate what is already going on. This is what we would like to do.